Welcome this afternoon to our Tucson Amateur Astronomy Association monthly meeting. This is our first Friday of the month meeting, and we'll be here every first Friday of the month, except of course January 1st, and we'll do the January 1st meeting instead on January 8th. So welcome everyone to our meeting. We're glad to see you tonight. We have our club members with us okay tonight. We're still working on Facebook a little bit. So, so if there's anything I need to say about Facebook in a while, Terry can let me know. Also, the next thing that we need for you to do tonight is something a little different. We're going to have two speakers tonight. Michael is going to speak to us about eclipses, and Mary is going to speak to us about seasonal objects in the sky. We also, after those presentations, are going to have breakout chat sessions. I got distracted because I had someone's picture come up on my screen and take over the screen. So, we're going to have chat sessions after the two presentations. And so we need for you to think now about which breakout room you would like to be in. And when you know which breakout room that you would like to be in, then you need to communicate that in the chat. Just type it in to Terry, and so that Terry can start getting the breakout rooms organized. So after our two presentations, the breakout room possibilities will be 4. One of them will be Michael, who will be our speaker on eclipses. And he will meet with people after the meeting, after his presentation, in a breakout room, and talk with them some more about eclipses if they'd like to do that. So if your choice, if our breakout room is to be with Michael, then you enter that into the chat. Our second choice will be Mary, who will do our observational astronomy group tonight, breakout group. And so if you would like to be in the breakout meeting with Mary, then type Mary into the chat. We will have a third group that will focus on imaging tonight. And if you would like to be in the imaging group, type in Tom, because Tom Rossmeyer will be doing the imaging group. And then the fourth choice will be if you would just like to remain in the main room and discuss things about TAAA. And Terry will be doing that group. So if you want to just talk about TAAA, you can type that in the chat. So now please make your decision and type a message into the chat about where you would like to be. Your choices would be Michael for eclipses, Mary for observational astronomy, Tom for imaging, or TAAA. And our first speaker is a TAAA member, and it's Michael Bakich. And Michael Bakich, as many of you know, has been a writer for Astronomy magazine for many years. And he sort of retired and moved to Tucson, and is really still working and still writing and still publishing some things with Astronomy magazine. So, but he's going to share information with us tonight that is included in one of his books on eclipses. And so he has a lot of really interesting information about eclipses, and that will be the topic of his presentation tonight. So Michael, are you ready to share your screen at this point?
Yes, I am.
Okay, so we can start anytime you would like to. I probably should announce to people about questions. I'm sorry, Michael, I did forget to say this. Please, if you have questions for Michael, please enter them in the chat and we will monitor that. Any question that has to do with clarifying what he said or clarifying something on the screen, we will try to immediately address. Other questions that are thoughtful, we will hold to the end and do all of those at the end. Okay, Michael.
Thank you, May. And good evening, everybody. Thanks for showing up in such a virtual way. I'm not used to talking like this, but I am used to talking. So this talk is going to be my picks for highlights of solar eclipses in the next 25 years. And the reason that I'm doing this talk is because of this book, which I co-wrote with Michael Zeiler. Some of you may know Michael Zeiler. He is a longtime map maker. Up until about 2011, he was specifically a terrestrial map maker. In 2011, he started making eclipse maps, and now he and his wife, Polly, run the really popular website, greatamericaneclipse.com. When I was still at the magazine, this was about a year and a half ago, he and I were chatting on the phone, and as you do, I asked him, what's coming up? What are you doing? What's the future hold for you? And he said, well, you know, I'm thinking about producing an atlas of solar eclipses. And there was a long pause, and he said, how would you like to write the text? Well, obviously I said yes, because here's the book. Now, in the book, we cover 56 solar eclipses from 2020 to 2045. 16 of them are partial eclipses. So those are the ones that, you know, if you're close, you can go see it, but people generally don't travel very far to see partial eclipses. 20 of them are annular eclipses. And if you're not familiar with that term, an annular eclipse is when the moon appears smaller than the sun. It's still a central eclipse, still lined up sun, moon, earth, but the moon appears smaller than the sun, either because it's farther from earth or because earth is a little bit closer to the sun and it looks bigger. So what you get in the middle of the eclipse is a ring of sunlight around the moon's disk. And the Latin word for ring is annulus. So these are called annular eclipses. And then for drama, there are 18 total solar eclipses in this time period and 2 hybrid eclipses. And hybrid eclipses are combinations of annular eclipses and total eclipses. And they come about because Earth has a curved surface, and at the beginning of an eclipse, the shadow might not reach all the way to the surface, so anybody under it would see an annular eclipse, but later on it does touch Earth's surface and you get a total solar eclipse. Here are the non-partial eclipses in the book. And let me say that everything that you see in this talk is one of Michael's fabulous diagrams from this book. He's really an artist. Now, as I started to think about this talk, I thought, wow, so many numbers, so many places, so many dates. I thought, how can I break the monotony here a little bit? And I thought, I could tell eclipse jokes. So before every eclipse, lucky you are going to get an eclipse joke. First one, what did the sun bring to the eclipse party? A light snack. Well, at least I laughed. You know, whether you laughed or groaned, this strange period of time that we're living in right now, as long as I get some response, I'm okay with it, because that tells me that you're okay. Okay, first eclipse on my list, October 14th, 2023, and it's an annular eclipse. The magnitude is 0.952. Wait a minute, what does that mean? Okay, the magnitude is a ratio. It's the size of the moon compared to the size of the sun. So for this eclipse, the magnitude is 0.952, which means the moon's size is 95.2% that of the sun. So if the magnitude is 1 or greater, it's a total eclipse. If it's less than 1, it's an annular eclipse. This one has a maximum duration of annularity of 5 minutes, 17 seconds. Not too bad. Here's the path. In general, it goes through North, Central, and South America. A little different look at the path, showing the degrees of partial eclipses on each side. And then we get a little bit closer. This eclipse starts in Oregon at the upper left. Eclipse California, goes through Nevada, Utah, Four Corners. And you can see here quite a diagonal swath through New Mexico and an even bigger one in Texas. Your question probably is, Michael, where are you going to be for this eclipse? It just so happens that Michael Zeiler lives in Santa Fe, New Mexico. And so when Holly and I visited right before, the pandemic struck, we talked about actually viewing the eclipse from his hot tub on his patio. But then we thought a little bit more about it. We are actually going to be here. This arrow shows the location of Michael's favorite ski resort, and it's right on the northern edge of the path. Now, why would you choose the northern or southern edge? It's because we want an extended view of what are called Bailey's beads, okay? And you can see them for this total eclipse image at the bottom. Bailey's beads are these last points of sunlight that you see right before the total part of the eclipse or right before the beginning and end of the annular part of an eclipse. And what they are sunlight penetrating between mountains, in valleys of mountains. And you get these little points of light that are called Bailey's beads because back in the during the eclipse of 1837, Francis Bailey discovered and described them. Why didn't the sun go to college? Because he already had 1,000,000 degrees. Okay, the next one is the total solar eclipse of our lives, August 2nd, 2027. Now this eclipse, wait a minute. Okay, 2023, you know what? I think I missed something, but I'm not going to talk about it. The total solar eclipse, April 8th, 2024, passes diagonally through the United States, from Texas-Mexico border, all the way up through Maine. The reason I'm not going to talk about it is you will, in the next 3.5 years, hear more about this eclipse than any that you can possibly imagine. If you thought we were inundated with information for the 2017 eclipse, double it, triple it, square it, and that will be the amount of stuff out there for the 2024 eclipse. It's going to be a really good one. 4 minutes, 27 seconds at the Texas-Mexico border, an extra second of totality if you go into Mexico. But I decided not to talk about it, and so that's what I've done for the last 3 minutes. Have not talked about it. Beyond that one, this August 2nd, 2027 eclipse will be the eclipse of our lifetime. The magnitude is almost 1.08, so the moon is 8% bigger than the sun. And the maximum totality, 6 minutes, 23 seconds. In fact, it's the longest totality that any of us will see in our lifetime. In fact, it won't be equaled until June 3rd, 2114, when the same duration of totality will occur. Here's the path of the eclipse. It goes pretty much over northern Africa. Take a little closer look. You know, a great photographic opportunity might be from the Straits of Gibraltar. with the sun high in the sky. But most people will be here in Egypt. The ability to combine a 6+ minute totality with the archaeological sites in Egypt is just something that many people will not be able to pass up. We're going to be in Egypt. If you look at the path that goes diagonally through Egypt, most people will fly into Cairo, which is at the arrow, but Cairo will see only a 95% partial eclipse. So you want to be out of Cairo during this eclipse. Take a look at the path. The center line of the path through Egypt, at no point during that center line path is the totality less than 6 minutes long. So there will, I predict, be millions of people that see totality from Egypt. Where are we going to be? Here's a little bit closer look at the location that I've picked out, and it's Luxor. This is the Temple of Luxor. It's one of the most famous locations in Egypt. And 6 minutes, 23 seconds of totality. The sun will be 7 degrees from the zenith, only 7 degrees from the overhead point, in a place at a time of year when rain or clouds are literally impossible. So most people don't dare predict that this eclipse in the future is going to be clear, or that eclipse. My friends, this eclipse will have clear skies. So get yourself to Egypt, and you can be at Luxor with me. Or if you like a little bit more astronomical tie-in, you can move a little bit away from Luxor, sacrifice only 10 seconds of totality, and be at the Temple of Dendera. Dendera is was the home of the famous Dendera zodiac, famous bas-relief that showed the sky, and it was painted on the ceiling. But it, like many of the artifacts from Egypt, now resides in the Louvre in Paris. But the eclipse of our life will be in Egypt in 2027. Start making plans now. This is the way the sky will look during the eclipse. And in the book, for all the total solar eclipses, we show the sky within 45 degrees of the sun. This is going to be a good one for the 3 planets visible. Venus is always going to be visible if it's above the horizon during an eclipse, and usually 10 to 15 minutes before and after totality. Mercury will be fairly close to the sun, only 10 degrees away, and Jupiter, even though it's 22 degrees away, is going to be bright enough that during totality, all 3 of these planets will be visible to your eye. You won't need binoculars or a telescope or anything. The 3 points of light will stand out quite well during this totality. Ready for a little bit more humor? Why did the teacher bring eclipse glasses to school? Because she has bright students. Okay, next eclipse. January 26, 2028, less than 6 months after the great eclipse in Egypt. This one's a little bit closer, and its magnitude, 0.92. Believe it or not, for an annular eclipse, as the magnitude goes down, the duration of the annular part of the eclipse goes up. This eclipse has almost 10.5 minutes of annularity. Where to be? South America, okay? You could, I guess, be on a cruise in the ocean, but South America is going to be the destination of most people. And you can see it from Ecuador, from northern Peru, but I think most people will see it, and you can see this long path through Brazil. Brazil will be the place to see it, because for tour groups, you can combine that with a tour of the Amazon River region and the rainforest there. And January is the Southern Hemisphere's summer, although this is close to the equator, so pretty much warm year-round. So this will be the annular eclipse in Brazil in 2028.
Michael, we have a
Yes.
question. I don't know if you want to answer this one now or later. The question is, how are the slopes and curves for the path of the eclipse calculated?
Very carefully. um, Michael Zeiler has been, he uses a set of data points for each eclipse that totals, I think he told me once, 30 million points. So he literally, his computer literally calculates 30 million points, and he can create maps that show the center line or show where the eclipse northern and southern boundaries are, and also the degrees of partial eclipses. So he can do all of that because he uses a massive database for each one of his maps. So that's pretty much how he does that. Okay.
Thank you.
I made a couple bucks selling fake eclipse glasses. Uh-oh. I'm not worried though. Those suckers will never see me again. Okay, next eclipse. Not very long after the last one, July 22nd, also 2028. This one has a magnitude of 1.05 and a worthy maximum totality in excess of 5 minutes. Here's the path, and it goes through Australia. A little bit closer look shows the path dead center Australia. If you're going, please be sure to check out Alice Springs and the nearby spectacular natural wonder that the natives call Uluru, but you might have heard it called Ayers Rock. Ayers Rock is a spectacular site in Australia. My wife Holly and I went there for the 2012 total eclipse, and don't miss Ayers Rock. This one also, right here at the end, just before it goes back into the ocean, the path covers Sydney, which is a spectacular city. You've probably heard of the Sydney Opera House. The number of photographic possibilities there, really limitless. But if you go to Sydney, and if you're going to Australia, you'll probably fly in there wherever you observe the eclipse from. Make sure you see the historic Sydney Observatory. Okay, this place has a wonderful history of Southern Hemisphere astronomy, which evolved quite a bit differently than Northern Hemisphere astronomy. So this will be July 2028, lots of time to plan to head to the land down under. And here's the way the sky will look. Mercury and Venus will be visible, Mars far enough away and too faint to be seen. But Mercury only 4 degrees from the sun, and even though Venus is about as far away as it can get from the sun, 44 degrees, Venus is always bright enough to see during totality if it's above the horizon. You know, the Aussies have a very good string of luck as far as this next period of eclipses. You can see there's an annular eclipse in 2042, but between 2023 and 2037, 4 total eclipses. Well, 1 hybrid, which is annular and total, and 3 totals. So the land down under is really the place to be in the next 20 years or so. How about a bit more humor? I was told I could look at an eclipse with a colander. I tried it, but it strained my eyes. Okay, March 30th, 2033. Magnitude 1.04, maximum totality a bit more than 2.5 minutes. This one's an odd one. It's one of those polar eclipses that kind of curves around. And I mention it because, as you can see there, it covers the northwestern part of Alaska. Take a little bit closer look here. The right side of the image here is the umbra, the shadow covering Alaska. And this part covers a little bit of Russia, really pretty much uninhabited parts of Russia. You can get to Alaska. End of March, oh boy, I wouldn't give very good chances for your weather prospects, but you definitely can get there. I think the best options here will be cruise lines that offer tours to people who want to see the eclipse because you have a little bit of mobility. And you can also stop and see Alaska and some of the highlights there. Not much going on in the sky, and the reason is because the sun is so low that all of the planets will be below the horizon if you go to Alaska or Russia or anywhere where the eclipse is total. Did you know there's an online resource for everyone who suffered retinal damage? It's a site for sore eyes. Run if you want. Okay, September 2nd, 2035. Magnitude 1.03, almost 3 minutes of totality. Here's the path. Wow, that's a lot of ocean. I guess you could go to Japan, but what I'm suggesting is something a little bit different. How about North Korea? How many of us have actually been to North Korea? Well, 2035 might be the opportunity. North Korea doesn't get many total solar eclipses because it's such a tiny country. And if you go, who knows who you'll see there. Here's the way the sky will look. The sun and moon will be in Leo. Venus, of course, will be visible. Mercury and Saturn, far enough from the sun, probably not going to see them unless you look through binoculars. And I never suggest that because it takes a while to find these planets, or if you're going to look for stars. And what you want to concentrate on is the glory of the solar corona. Why shouldn't teachers let students outside during the eclipse? They need to protect their pupils. It's true you don't. Okay, total solar eclipse, April 20th, 2042. Magnitude 1.06. Duration, almost 5 minutes of totality. Oh my, this is even a worse path than the last one, at first look. But now let's take a closer look at the west coast of the US, which is over on the right-hand side here. See Portland near the top and San Francisco near the bottom. And if you board a ship and sail just 1,200 miles to the center line from San Francisco, you'll be able to see a totality that lasts 2 minutes and 23 seconds. Now the sun will be fairly low, 3.5 degrees above the horizon, but it's the ocean. So there's not going to be anything in your way unless there are some clouds. Now, 1,200 miles aboard a cruise ship is not a long voyage. So you can go farther than that, and I'm sure some cruise companies will. The farther west you go, the longer the totality, and also the higher in the sky the sun will be. Here's the eclipse and the sky. Both Mercury and Venus probably will be visible to the naked eye, certainly Venus. Mercury, because its position is midway between Venus and the sun. So during the total part of the eclipse, you'll be able to see these two planets. For sale, never used eclipse glasses. I'm selling them to raise money for my eye surgery. Okay. Remember when I didn't talk about the 2024 eclipse that goes through the lower 48 states? I said there'd be a 20-year wait for the next one. Well, here it is, August 23rd, 2044. Unfortunately, it's not that great. The maximum totality is just above 2 minutes. And let's take a look at the path. It comes down from Canada and only really touches 2 states. And those are Montana and North Dakota. Let's take an even closer look. This curved line is the Canadian border. And you can see Montana here and North Dakota up in the upper right. Now, if you have to stay within the United States, probably for legal reasons, you want to get as close to the Canadian border as you can. Maybe base in Great Falls, Montana, or Minot, North Dakota, and try to find some clear area. And a lot of roads are make this an easily accessible eclipse. You might be better, you'll see 15, 20 seconds longer totality if you do go up into Canada. But again, You can see this from 2 states in the lower 48. And here's the sun. Unfortunately, Mercury and Venus, both below the horizon. But Regulus, the brightest star of Leo the Lion, is only a degree away from the sun. So if you go to this eclipse, and if it's clear, and you use binoculars to view the solar corona, you'll see Regulus quite close to the sun. This one's for the English teachers out there. What do you call 3 eclipses lined up next to each other? An eclipses, dot, dot, dot. I'm sad to report that that was my last joke. Okay, this is my last eclipse, August 12th, 2045. And it's a great one. It's 25 years from now, but this eclipse is worth staying alive for. The magnitude, almost 1.08. The maximum totality, a worthy 6 minutes, 6 seconds. What's more, take a look at this path, diagonally right through the United States. Let's take a closer look, okay? And an even closer look. This one starts in California. You can see California, Nevada, and Utah get terrific paths. And then Colorado and Kansas and Oklahoma and a little bit of Texas and just a tip of New Mexico and Arkansas, a little bit of Louisiana, Mississippi, Alabama, the southwestern part of Georgia, and look at Florida. I mean, it literally covers the state of Florida. Now, if you think back to the Egyptian eclipse, 2027, as the path goes through Egypt, remember I said that at no part along the center line is the totality less than 6 minutes. The same holds true here in Florida. If you're in Florida, and if it's clear, wherever you are along this center line, the midpoint between the northern and southern limits, you will see 6 minutes or more of totality. Spectacular. I mean, really, this is something to point toward. Here's the sky, sun close to Regulus again. Probably the only planet visible will be Venus, even though it's 37 degrees away. So this eclipse in 2045 is another one. It's the last eclipse in the book. It's the last eclipse in my talk. And so if you're interested, you can purchase this book from greatamericaneclipse.com. And let me give one more plug for Michael, because he has produced an amazing globe. I didn't have any part of this. Also available on his website, but this globe shows not just the next 25 years, but every total solar eclipse that happens on Earth in the 21st century. But I will say, in closing, my wife and I moved here almost a year ago. At the end of this month, it will be 1 year. And that very first week, there was a TAAA meeting. We went and we became members. And so I've seen some in person and some via Zoom, every eclipse, or I'm sorry, every talk since then. And I thought, wow, there's some great speakers that have done lectures. How can I set my talk apart? And I thought, I know, with a gift. So I will give the TAAA library, the next time we're together, a copy of the Eclipse Atlas so you can all enjoy it. Thank you very much, and I'll turn it back over to May.
Yes, wonderful. We would love to have a copy of the book. Thank you so much. So that's great. Okay, now we have a question, and I lost it for just a second here. Okay, this is from Alan, and it is why does the shape of the circles in the path of the eclipse change shape? What does that represent?
That is a great question. Okay, it changes shape because Earth is not flat. We know this. Spread the news. Earth is not flat. And so when the eclipse starts, it's at a very steep angle. It's really, let's take total solar eclipses. They begin on Earth's surface at a place where the sun is just rising. And so from the perspective of the sun and moon lineup, Earth's surface is very curved at that point. And so what is a circle is actually quite spread out at that point. Now, as the eclipse progresses and as it gets overhead or to the point of greatest eclipse, then the projection of the shadow on Earth's surface is much more circular. And then it gets less circular as it moves toward the end of the eclipse. Really, really good question.
I just also wanted to mention to you, Michael, that Doug Smith is our librarian, so that when you graciously donate your book, it will end up with Doug Smith. And you can give us, you can give it to one of us to give to him, or you can give it directly to him. Just however that works out for you will be great.
Okay. And, depending on how my jokes went over tonight, I can either inscribe it or not.
Oh, well, we always love to have inscribed books.
Okay,
So.
no problem.
And Doug usually appreciates humorous things anyway, so as librarian, he will probably particularly enjoy it.
May, Doug had a question also.
Oh, he did. Okay. Yeah. Oh, Doug says, do you know if the major cruise lines have made arrangements yet for 2024?
I don't know yet. This is a little bit early. I mean, I'm sure cruise lines are thinking about it. At the magazine, we usually planned for eclipses 2 to 2.5 years out. And so they would not be thinking of working with a tour company yet. But I'm sure that cruise lines, because they have to work far in advance, probably are reserving the ships for that and many other eclipses even now. Okay.
Good. Thank you. It's helpful that you know something about how that works. Okay. Well, Michael, we really appreciate your presentation so much. And Michael volunteered and came up with the idea for us tonight to try to have some session time with speakers where people could interact with speakers. And it's just really a great idea to do that. So we appreciate that and appreciate his willingness to stay. So now we're going to our next presentation, and Michael is going to hang around with us until after Mary's presentation, when we divide into groups. So thank you for doing that, Michael. And next we have Mary Turner, and Mary, you can start your screen sharing, I'm sure at any point here you would like to. Mary is going to cover her seasonal objects in the sky that she does quarterly for us. And she's our master astronomer. And Dr. Turner is really experienced with this and gives us great information and talks. So thank you so much, Mary.
Okay, well, good evening, everyone. Nice to sort of see you all again, or at least those of you who had your video showing earlier. I'm sort of getting used to presenting these things while sitting down, but as most of you know, I'm much better when I can move all around the place. But this will be my standard presentation on some of the objects that are in the sky. Sort of a little different in that my main impetus for starting doing these so many years ago was to try to present some information that you might be able to use if you were going to a star party, just a little bit of information you can tell the kids or parents or whoever comes to look at things through your scope. And you can do that with this as well, but obviously we won't be seeing seeing too many school kids using our telescopes, at least for another little while, which is a shame because Halloween is coming up, and I know a lot of us liked putting our scopes out on Halloween so we could let people look through the telescope. I remember the days in my old neighborhood where kids wouldn't take candy until after they looked through the telescope because they didn't believe they could actually have both. And they wanted to make sure they got to look through the telescope before we said, nope, you had candy, you can't look through the telescope. But hopefully by next Halloween, things will be a little bit more normal. So look at some of the objects I'm going to talk about this quarter. Cassiopeia, obviously this time of year, there are just certain constellations that dominate the sky, and they have some good stories associated with them. I want to talk a little bit about Jupiter. Prime observing for Jupiter has passed a little bit, but Jupiter is always worth looking at. And then a couple of other interesting objects, several Messier objects, but globular, a globular cluster, some double stars, variable stars, an open cluster, and some galaxies. So let's start by talking about my constellation for the quarter, and of course Cassiopeia, Queen Cassiopeia. We can see sort of what the mythological figure looked like. And of course, we can all see from looking at this mythological figure, it is oh so obvious from just looking at a W of stars. I think we all agree that we can definitely see a female form in this W. Sure we can. Cassiopeia was the queen of Ethiopia. Her husband was King Cepheus. Her daughter was Andromeda, and she and Cepheus had possibly up to 17 sons. One of the few instances where you only hear about the daughter, the sons just are sort of in the background there. But among other things, Cassiopeia was, to put it mildly, a bit on the vain side. Okay, she was exceedingly vain. And she boasted that she, and more importantly, her daughter Andromeda, were more beautiful than the sea nymphs, the Nereids. And since they were, related to the gods, inferring that they weren't the most beautiful thing around was not a good thing to do. Gods tend to take those sort of things personally, and gods like to get revenge. That's just what they do. In particular, Neptune or Poseidon, again, Greeks versus Romans, sent floods in response to this to destroy the land of Ethiopia. He also sent along the sea monster Cetus to terrorize it when the floods weren't tearing it apart. So basically every day when the tide came in, the sea monster would come up on the shore, and if any of the Ethiopian people happened to be within reach near the shoreline, they got eaten. And obviously, if the land was being flooded on a daily basis, all the crops are going to be destroyed. So if you were lucky enough to avoid being eaten by Cetus, you didn't have anything to eat. So all around, not a very good situation for the king. So the king, obviously, being a good king, weird wife, but he was a good king. So he went to his local oracle. All good kings should have a local oracle to find out what he should do to try to protect his land and to protect his people. So the oracle came out from that little gas chamber rock thing where oracles tend to reside and came up with the most obvious answer. I'm sure we all could have thought of it on our own. Chain his only daughter to a rock and sacrifice her to Cetus, and that should please the gods, in particular Poseidon. So, of course, if the oracle tells you to do something and you're a good king, you're going to do that. So the king had his daughter chained to the rock, waiting to be eaten by the sea monster. Fortunately for Andromeda, just as Cetus was just about to climb up onto the rock to, have his snack for the day, Perseus, who was returning with the head of Medusa from all of his little tasks, happened by, and he saw this and said, "Hey, she looks sort of cute. Why is she gonna get eaten by the monster? Let me see what I can do about it." So he made a deal with King Cepheus that he'd save his daughter if in exchange he got to marry her. And of course, the king initially didn't agree to the bargain until he saved the daughter and then tried to renege. But eventually, Andromeda and Perseus did get married. Cassiopeia herself didn't exactly get away scot-free from all of this. Because of her vanity, she was condemned to spend an eternity in the sky, rotating around the North Pole. Half the time, she is in a very upright, regal position. However, the other half of the time, her upside-down position, with the legs flailing, is not quite so ladylike. So, moral of the story, don't say you're more beautiful than the gods. It's not a good thing. In Arab mythology, the stars of Cassiopeia are the fingers of the tinted hand, possibly representing Fatima, who was the daughter of Mohammed. In the northern climates, the stars combined with some of the other stars from the Perseus constellation form a moose antler, and these stars are the 5 reindeer stags in Siberia. In the South Pacific, where you look at the stars and obviously at the opposite orientation, the stars that we see as Cassiopeia, Perseus, Andromeda, Triangulum, and Aries form the constellation referred to as the porpoise. So that's just a little bit about Cassiopeia and the perils of vanity. And this image, I'm sure most of you have seen this one quite recently. I guess about somewhere in the vicinity of August 25th. And it's why I decided to talk a little bit about Jupiter, even though it's not necessarily right now in prime viewing space when we go out at night. But I just was blown away by this picture, and that just got me thinking again. So I decided we'd talk a little bit about Jupiter, because even if it's not in the prime viewing location, Jupiter is still a wonderful object to look at. Obviously, it's the biggest planet in our solar system. And even with moderate telescopes, you can see noticeable detail. Obviously, not quite the detail you can get with the Hubble, but it's still definitely a beautiful object to look at, especially when you look at it in a more wide field view, and you also get to look at some of the moons, and we'll talk about some of the moons as well. This particular image is a combination of near IR visible as well as ultraviolet, but what's nice to see is that the Great Red Spot is definitely there and visible, because I'm sure we've all been reading over the last decade or so about, the Great Red Spot has been there since the time of Galileo, but it looks to be fading. It looks to be getting smaller. Is it going to disappear? Latest scientific data sort of indicates that the cloud structure is definitely changing, but it doesn't look like it's going to disappear anytime soon, which is a good thing. Some of the numbers about Jupiter. The diameter at the equator is 142, let's call it 143,000 kilometers. Its mean distance from the sun is 778 plus million kilometers. And it has a relatively circular, slightly elliptic orbit around the sun. It, for the size, spins quite rapidly. The length of the day is just under 10 hours. The length of the year, however, is about 11.9 years. It weighs about 318 times as much as the Earth, which is not, it's within an order of magnitude of what it might have needed to accumulate mass-wise for it to actually have achieved some sort of, stellar type properties, for it to have formed into a star of some form, but still nowhere near enough. You can put a little over 1,300 Earths within the volume of the gas giant Jupiter. The density is about 1.326. Water defines this as with a density of 1.000. So Jupiter is a little bit more dense than water, but it certainly is not a rocky planet. Earth's density is closer to 6, so 6 times as massive per volume as water is. So again, it's a gas planet. It has very little solid structure to it. The gravity is about 23.1 meters per second, so significantly different than ours, which is 9.8 meters per second squared. Mean temperature is a balmy minus 110 degrees C. Okay, show of hands, how many of us wish our temperature was a little bit on the cooler side right now? Not sure minus 110 C is as bad as this plus 110 F we've been living through for the last, seems like forever. And obviously, one of the interesting things about Jupiter is its number of moons, and that number is ever increasing. Last count I've heard is about 79. Most of them are moons simply because they're currently orbiting Jupiter. But remember, if you've been listening to the news or whatever lately, for a very short period of time, we're going to have a second moon, because the booster rocket, one of the stages of a booster rocket has been caught into the gravitational pull between the moon and the sun, and is going to act like a moon for some limited period of time. So, any sort of space junk that just is floating by can effectively be called a moon under certain circumstances. Many of Jupiter's moons are little more than rocks, but it's still an interesting number, and also interesting to know that they can be actually identified, obviously mostly with other types of telescopes. You're not going to discover new moons with your personal telescope, sorry. Jupiter itself is the largest of what we call our gas giant planets. We can only see 4 of the moons with our typical telescopes. These are referred to as the Galilean moons, because Galileo is given the credit for being the first to identify these. A couple of people did about the same time, but we all go back to the story of Galileo and the issues he had with the church as a result, in part, of his explanation of the Galilean moons and the fact that they did revolve around Jupiter, not around the Earth. And this in some ways led to repercussions with the church. But again, a lot of the issues that Galileo had with the church were more self-induced via, just like Cassiopeia, vanity than actually any true discussion and discrepancy on the science involved. Lots of the planets of Jupiter have been found in relatively recent times. You go back probably when I first started doing these talks, there were probably in the 50s-ish of moons, and then in the 60s of moons, and now we're up to 79. So telescopes like the Subaru, the Canada, France, Hawaii telescope, again, some of these moons are little more than rocks. And there actually are four very small moons that actually are inside the orbit of the Galilean moon, so closer to the surface. Jupiter also does have a ring structure. It doesn't have the reflectance of Saturn's. It doesn't, so for us from our telescopes, it doesn't have quite the beauty that Saturn does. And obviously the most notable features of the planet itself are the climatic structure in the weather bands, obviously the Great Red Spot. And I do, since I'm on my own computer right now, I want to see if this works. Okay, and I found this on the web, and I'm easily amused, as you all know. So let me see, let me go back here, and I'm going to pause this for a second. So at the very center is, of course, Jupiter, and around Jupiter are the 4 Galilean moons. The interior moons would be between Jupiter and the closest moon, so you're not going to see it on this. But the rest is simply showing the names of the names and the paths of the other some amount. This is an older video, so it probably doesn't have all 79 moons, but it has a lot of them. And since most of you have been forced to listen to many of my talks in the past, you'll notice they have names like Leda, Lysethia Thermisto. I like that name. Let's see, Itne, and I'm probably getting some of these wrong pronunciation-wise. Persephone, Hegemony, Philo. Oh, I got to see what that one was. Come on, stop here. Philophrosine. Okay, Brad, if you want to pop up what the real pronunciation is, you can tell me. But why I'm mentioning some of these. The moons of Jupiter / Zeus are named after the lovers and or children of Jupiter and Zeus. So you would have thought that, based on all of the stories I've told you over the last 15 years or so, that they actually never would have run out of names for these moons. But we also have the wonderfully named Jupiter 67. Over here we've got Jupiter 63. And Jupiter, that would be 59. So actually, apparently, they ran out of lovers of Jupiter. I didn't think that could ever happen, but they just ran out of names. But now let's go back and just let it watch through a little bit. And you can see that you have prograde motions, you have some retrograde motions, but other than maybe Thermisto and a few of the other ones, most of these, based on the orbits, are probably simply items that were captured by the gravitational mass of Jupiter. But as you can see, Jupiter does have a lot of moons, and they're just all over the place. Thought that was sort of interesting. But again, you all know I'm easily amused. Okay, so the red spot itself, just again, sort of an idea of how to talk to kids in particular. It's basically a high pressure storm system. If you want to think about it sort of as an anti-hurricane, which tend to be low pressure systems, but it's definitely a storm. Galileo saw it in his earliest observations. Obviously, he didn't call it the Great Red Spot. It's just, and what's happened is, by looking at his drawings and other drawings that have been made of observations of Jupiter over the last 400 plus years, it appears that it is this same storm. Remember, Jupiter is a gaseous type planet. There may be a very, very small core, but it's largely a combination of gases and dusts, etc. There's a lot of variability to the outermost surface, if well, not a good term, but the outermost structure of the gases that we see. There are color changes, changes in visibility, changes in orientation and intensity of the different storm regions. So it's a very, very active planet and very interesting to watch, but always one of the things you can count on is looking at that Great Red Spot. Okay. And this basically sort of is a NASA picture, simply about 8 kilometers above the local clouds, and it's just a bunch of swirling gas. Okay. The bands are basically almost weather fronts. This is a series of images taken during Cassini. The reason we have this structure is because the winds are extremely strong, not the strongest, fastest winds in our solar system, but they're right up there. And they change between the different zones. So as they kick up different amounts of different types of dusts, we get this different these colorations, and we can see sort of the frontal effects in all of this structure. So a little bit on the Galilean moons, going from the closest out. Io is the third in size. It has an orbital period of about 1.8 days. It also is volcanically active. Indeed, so far the most volcanically active object that has been identified within the solar system. And this volcanic activity is simply because it has enough mass and it's so close to Jupiter that just like we have our tidal bulges that cause the high and the low tides on Earth, basically the gravitational attraction forces of Jupiter are so great, it's just squeezing squeezing the moon back and forth, leading to this significant amount of volcanic activity. Europa is the smallest of the Galilean moons. It rotates around in a 355-day period. Its surface is made of ice, but there is some evidence of existing liquid water. There is some molecular oxygen on the surface. Hence, there are a lot of folks who would like to visit Europa to look for evidence of other forms of life. Obviously not human type life, it's a little bit too cold out there, but the chemical system necessary to support life does exist on Europa. Ganymede is the largest of the Galilean moons and indeed the largest identified moon in our solar system. It's actually larger than the planet Mercury. It does have its own magnetic field. So again, it's relatively large. Its period around Jupiter is about little over 7.5 days. And the fourth of the Galilean moons is Callisto. It is very icy, not necessarily water ice. Methane also forms ice. 16.7 day period. It has been heavily impacted by all of the debris floating through our solar system in that region, including probably a lot of the things that are now those other moons of Jupiter. So it has the most cratered surface within the solar system. And this is Amalthea is one of the interior moons, and you can see, again, on a scale of things, it just happens to be a rock that's just orbiting around the planet. Calling it a moon is by definition correct, but sort of stretching the truth just a little bit. And then there are the other Galilean planets, and you can definitely see that they all show evidence of these three definitely show evidence of being impacted by meteorites, other types of debris. Okay. So again, Jupiter was much better to see a couple months ago, but if you haven't gone out and looked recently, go out and give it a show. Next object will be Messier 15, which is located in Pegasus, and it is as we can see from looking at the picture, a very nice little globular cluster. And this is a Hubble picture taken by WIFPIC. still nice views even through one of our telescopes. It's about 40,000 light years away. Its brightness is about 6.2, which brightness of about 360,000 times that of our sun. The brighter stars have brightness on the order of 1,000 times that of the sun. Parent dimension is about 18 minutes. Tidal radius is about 210 light years. So it's, for a globular, it's on a reasonable size. As it is a globular, some of the oldest objects within our universe, they're about 12 billion years old. It does have an extremely dense core for a globular, and this could either be due to the collapse of the stars as the stars age, or it could be that there is some type of supermassive object, probably a black hole, near the core, near the center of the cluster. Within Messier 15, there have been 3 planetary nebulas that have been discovered. Questor 468 was the first one that was found. The central star is burning at a temperature about 40,000 degrees centigrade, and the gas was ejected probably about 4,000 years ago. So very old, but the stars are still, going through their life cycles. Another interesting object, or 2 or 3 or 4, is Gamma Andromedae, or Almach. So here's Almach here, and here we can see an image, and there's where I grabbed the image from, and we can see a bright whitish yellow star and a cooler, a white bluish type star here. So very clearly we can see 2 stars when we look in the vicinity of Gamma Andromedae. However, it actually is 4 stars. An Almach is a type of wild cat, in case you were interested. And as I said, it's actually a quadruple system with a magnitude of 2.1. We have the A star with a magnitude of 2.3, about 355 light years away, 2,000 times the luminosity of our sun, and about 80 times the diameter of our sun. It is a yellow star, temperature of about 4,300 Kelvin. Remember, the sun is about 5,600 degrees Kelvin. The other star, the C star, is actually the dimmer of the 2 stars. The B is a spectroscopic binary pair, so you're not going to recognize that there are 2 stars there. It's just using spectroscopes. You can recognize this as actually being a 3-star system, with this being a spectroscopic binary. The magnitudes are about 5.1 and 6.3. The temperatures are 12,000 and 10,000 Kelvin. Again, the brighter star is this double, and the combined mass of the 3-star system is about 9 times that of the sun. So compared to the A star, even the whole group of stars is much, much smaller. But definitely going to be able to see the 2-star system in the telescope, and you will definitely see a definite color difference between the 2 stars. Okay, another star interesting to look at is Omicron Ceti, or Mira, right here. And what's interesting about Omicron Ceti is it is a variable star. And this is data in the visible and the ultraviolet. Also a double star, Myra, as well as a companion, in this particular case seen in the visible. But again, the most interesting aspect of Omicron Ceti is that it is a variable star and it has a very well-defined periodicity. Okay. So let's talk a little bit about the numbers. And the Mira simply means remarkable, and it is. It was the first recognized pulsating variable star. Originally, it was thought to be a nova. There are writings going back to Hipparchus that seem to denote a description of this particular star. Magnitude ranges from 3.4 to 9.3. So there are going to be some periods of time where it's almost invisible to our eyes. And that period occurs in just under a year, about 11 months, 332 days. The Myra itself is a red giant. The companion star is a white dwarf, and they're only separated by about a little over a half an arc second. They're about 400 light years away. The luminosity is about 15,000 times that of our sun. Again, a red giant, that shouldn't be unexpected. And the temperature is a coolish 2200 degrees Kelvin. The next object we were going to take a look at is Messier 34, which in this case is an open cluster. We've looked at a globular. Oops. Now let's take a look at an open. Sorry, my mouse button moved the wrong way. And here is a very nice picture of this open cluster. It is not as dense as some other open clusters, but it is definitely very, very pretty. And I like things that are very, very pretty. Its distance is about 1,500 light years. It's, as with most open clusters, it's going to be young, in this case about 180 million years old. Remember, open clusters are relatively young because the stars form together, but the gravitational forces external to those stars are going to start pulling them apart relatively quickly on an astronomical scale. Come back in another couple 100 million years and you may or may not know that those stars were ever associated with each other. There are about 100 stars within the grouping with a magnitude of about 5.2, so it's spread over a relatively large region, so you are going to need a telescope to see it within its full glory. Apparent diameter is a little more than the moon, about 35 arc minutes. Yeah, and that which corresponds to an actual diameter of about 14 light years. So 100 stars over 14 light years. Seems like such a, this is such a huge number with such a small number of stars, but I guess when we look far enough out, they still look like they're close together. Space is just, in some places, very well populated. In other places, it's very, very sparsely populated, which is interesting scientifically. The next object will be Messier 110, also in Andromeda. And Messier 110 is a galaxy. We like galaxies. It is an elliptical galaxy. It's an older galaxy, or a galaxy that has, or the remnants of a galaxy that has survived. I'm holding up my fingers in phony little quote marks, an interaction with another galaxy, or two or three. Little bit of information about Messier 110, although it is sort of considered a dwarf galaxy. again, an elliptical galaxy, sort of lost most of its shape and form. It is a companion to M31, which is why it's lost most of its shape and form. But it still does have about 10 billion, and that is with a B, stars. It also has at least eight, I can read, known globular clusters within it. The apparent size is about 20 by 13, so smaller than the moon, but again, going to be noticeable if you look at it at the proper magnification. That corresponds to a diameter of about 15,000 light years. So for a galaxy, that's relatively small, but it's still relatively large object. It's somewhat dim, visual brightness of 8.5 because it's spread over such a large area. Again, it's definitely a telescopic object for the most part. It's about 2,900 light years away. What's interesting is you'll notice in the image, there are a couple of little red arrows I pointed to these little dark regions. So this is an elliptical galaxy, a dwarf elliptical. It's very old. It's already interacted and lost its structure due to its proximity to M31. But those dust clouds indicate that there is star formation going on. Normally, we wouldn't see star formation in elliptical galaxies, old galaxies. Could be a result of the energy interchange from its interactions with Messier 31, sort of unknown at this point in time, but having dust clouds and star formation in elliptical galaxies is somewhat unique with Messier 110. And Messier 103, we talked about Cassiopeia. Let's take a look. Yeah, in this picture, she's sort of in her unladylike repose. But here's Messier 103, which is another open cluster. Isn't that pretty? Not quite the diamonds on black velvet as we'd see in Hercules, but definitely pretty. Messier 103 has about 170 stars. It's about 10,000 light years away. This was the last object actually added to the Messier catalog by Messier. The other objects were added afterwards. Magnitude is about 7.4, 6 by 6 in size. Again, it's an open cluster. It's not a galaxy. That corresponds to about 17 light years. Its age is only about 25 million years, but that star is indeed a red giant. So basically a star that formed probably very large initially. The larger the stars are initially, the shorter their life expectancy. And NGC 253 is another galaxy. In particular, this is referred to as the Sculptor galaxy. And here's a pretty picture of it. I like spiral galaxies, and you can definitely see some nice structure. Still nice star formation regions as well. This was actually discovered by Caroline Herschel. It's part of a Sculptor galaxy group. It's called the Silver Coin Galaxy, and I guess that's a reasonably appropriate name. It's very bright. There are a lot of dusty regions in it. It's referred to as a starburst galaxy. There are bursts of star formation. Brightness is about 7.1, and it's about 10 million light years away. Good, we don't want galaxies overly close to us. Parent dimension is about 25 by 7, so not quite the width of the moon by about a quarter the width of the moon, which corresponds to about 70,000 light years across. So certainly smaller than the Milky Way galaxy, but still worth talking about. Again, starburst galaxy, there's lots of active star formation. There is a lot of X-ray and gamma radiation that are emitted from this galaxy. There are multiple massive black holes as well. We all like massive black holes. And the last object for this quarter is Messier 77 or NGC 1068, which is another galaxy. And this one's face-on spiral. Isn't that pretty? Oh, look at that. Yes, we like these. Okay, it is a barred spiral. It's about 45 million light years away. Brightness is 8.9. Dimensions 7 by 6. So since it's so far away from us, it's not going to appear very large to us when we look at it in the telescope. But that does correspond to a more galaxy-like 170,000 light years across. Its mass is 1 trillion times that of our sun, a reasonable sized galaxy. It does have a black hole that has a mass of about 15 million times that of our sun. It's what's referred to as a Seyfert galaxy, so it has a very large expansion velocity, better than 1,000 kilometers per second, gives off lots and lots of infrared radiation. Again, the central mass is about 10 million suns, and the diameter of the core right in here is about 10 light years. So you can see the whole galaxy is about 170,000 light years across, but the central core is about 10 light years, where a significant amount of the mass is, of course, concentrated because there's a black hole there. So that ends my presentation. Thank you very much.
Well, Mary, thank you so much.
Okay, and I will stop sharing.
Okay.
I don't like to share.
Well, it gets complicated sometimes too. Okay, let's see. I don't have questions for you, I don't think, in the chat right now. Does somebody have a question for Mary?